In this tutorial, I'm going to explain how to simulate an RC low-pass filter using LTspice software. First, open LTspice software and then go to a new, and after that you can add resistors and capacitors using the shortcuts on the toolbar. And if you need to rotate or mirror the components, you can use the two icons on the toolbar, and you need to remember you can only rotate or mirror your components before releasing them. So once you click on the resistor or the capacitor value, use the rotate or mirror signal before placing them. And after that, you can add ground terminals using the shortcuts. And to add the voltage source, you need to go to components, add components, and then select the voltage source, and you can place it. Once you place the component, press escape button to release that item. After that, you can add wires. You can place the wire by clicking the left mouse button. After adding wires, we are going to add resistor and capacitor values. For this tutorial, I'm using 3435 registration number. So your resistor value will be 3435 divided by 10, and the capacitor value will be 3435 divided by 1000. So I'm going to change the R1 value as 343.5 ohms, and capacitor value as 3.435 microfarad. You need to place U for to denote the microfarad. And after that, we can add labels for outputs and inputs. For this simulation, I'm going to add an output label named as Vout. After adding the label, we need to rename our voltage source. I'm going to rename it as AC. You can use either AC1, AC2, but in here I'm going to use AC as the voltage source name. And after completing all these things, we can start the simulation. To start simulation, press run, and I'm going to use the AC analysis. Type of sweep will be decade, and I will place 10 points per decade, and start frequency as 1 Hertz and the stop frequency as 5 kilohertz. You can decide that value. For this tutorial, I'm going to place 5k, that means 5 kilohertz. And this is your simulation window, and you can use this probe to add uh, the variables which need to be plotted in the simulation window. So I will press this Vout terminal, and this bold line represents the gain of the output signal, and this dotted line represents the phase change of the output signal. And you can right click on this Vout label on the top of the graph to add the cursor. By adding this cursor, you can find out the represent relevant values of x and y axis along the graph. We know for an RC low pass filter, cutoff frequency will be lies at minus 3 dB gain from its output. For this RC filter, we know it is a passive filter, so there will be no gain provided to the output. So minus 3 dB will be equal to the minus 3 dB in this graph. So you can see when we place the cursor at minus 3 dB, frequency free, when we go along to the frequency line, we can see the frequency value at that minus 3 dB gain is equal to the 135.7 or something like that. It is around 135 hertz. So it is the cutoff frequency of this low pass filter. Using this method you can find out the cutoff frequency and also the phase change. If you go along this minus 3 dB cursor line, you will find out the phase change is equal to the minus 45 degrees. So using this window you can find out all these values which are relevant to the point on the graph with this cursor.